if we see it, if you have a look at it, maybe you spend a couple of minutes on that, and from this plot, if someone asks you that suppose this data, because the data is not known to you, let me give you the data. So this plot is basically talking about, there is a data set called MBA. So MBA means our Master in Business Administration and all. So there are some students data for MBA. And how many data points are there? There are 773 data points. Data points are nothing but observations, rows, instances. There are a lot of names to these data or data points or rows, right? So there are 773 observations in this particular data. And there are 3 columns, namely the serial number, then there is a GMAT score, and the third column is the work experience, right? So the data is for the student who have applied for the MBA. Their GMAT scores are given and their work experiences are given, and this particular plot, which is bar plot, is plotted over here and with its GMAT scores. So these are GMAT scores, and these are number of students, right? So serial number is 1, 2, 3, 4, like that. 773 students are there, and this data is given to us with their respective GMAT scores. So someone has scored 200, not 200, maybe 450 or 600, 620, 680 or something like that, right? So the GMAT scores are given. So let us have a look at it. If you want to have a look at it, first let me show it through R as well. So this is the R studio, right? And here I am going to import this file. So we are going to see all these functions in detail when I am going to take the basics of R detailed video. Okay, that time I will explain all these functionalities, basic functions, etc., etc. For now, just understand how the plotting works in R environment, right? So read.csv is the function. I have given the path to the file, and the file name is mba.csv, and I am going to store that file into a variable called MBA, right? So I am storing it, and now you can see over here the MBA data set is there, which is having 3 different columns: data serial number, workx, and GMAT, right? So there are 773 observations and 3 variables. So if I want to open this file, I can open it like this, and you see here data serial number, workx, and GMAT are my columns, and there are 773 entries given there, which means these are my observations, these are my rows, right? So those many students are there. Data serial number is nothing but those many students are there. 773 students are there, and their respective work experience. So normally whenever we apply for MBA sort of a course, right, so most of the times you will find that people will they first take the graduation degree, and then they take some experience on the field, and then they get back into the management degree admission or management related courses. So same thing happening over here. So that is why the work experience column is given and GMAT column is given. Now when we have plotted over there, that particular plot when we were looking at, so let us look at the graphical techniques, and this is the bar plot. Okay, so bar plot is directly a function available in R, wherein I am just using that function and passing this GMAT score data to this bar plot function. So when I say that, what happens is this bar plot let me minimize this thing. Can I close this? I don't know, maybe everything will shut down. So let me put it over here only. Okay, so when I execute this bar plot function, okay, with MBA $gmat, so this is a syntax. I will explain why this syntax and everything when we will learn the basics of our code as a whole. Okay, right now I just want to give you the feeling of how the plotting done in R. So bar plot MBA $gmat, I am pass on the score, and this is the plot, and this is the same plot which we are looking through the slides, if you can see over here, right? So there are GMAT scores given over here, and these are the number of students. So each student's GMAT score is represented by a bar, but because there are 773 observations, these bars look like so clumsy that it's very difficult to understand that this is a bar plot, right? So let us get back to our slides once again, and this is what we were discussing about. So this is the plot given to us, and in that plot there are 773 observations, and these are the scores. So 600, 400, 200, 0, these are the scores plotted on y-axis. These are GMAT scores, and these are number of students. So if you see, when we plot a bar plot, first of all, the understanding over here is it is not a better representation when we have larger data set, because the 773 observations are just too many for Boxplot to plot. You cannot make out a single bar separately, right? But the only understanding you can get from this plot is that probably every student in this data have scored more than 600 marks. That's it. Not more than that you can make out of it, right? And that is why bar plot is only significant when we have a smaller number of data sets, like 25 observations, 30 observations, 35 observations. So you can make out, so you will get a bar like structure like this, right? So if there are 10, 15, 20 bars, then you can make out, you can do some analysis, you can come up with some sort of understanding out of that particular plot, right? So this is one plot for you guys, that is bar plot. Now we will try to understand another plot, and that is called histogram, right? So for the same file, for the same MBA file, now I am using the histogram function over here, HIST, and I am using the same column, that is GMAT scores, right? So when I plot this, my histogram will look like this. So this is my histogram for GMAT. Now if you see this particular plot, right, then what are the understanding you can make out from this plot? What are the analysis can you come up with this plot? First of all, what is histogram? So histogram is nothing but it is a frequency distribution. It is a frequency distribution, right? That is how many observations take the value within a certain interval, right? So if you see over here, it is a frequency distribution, means from 600 scores to probably this bin size. These are called as bin sizes, right? A certain interval is nothing but my bin size, right? So 600 to maybe 620 is one bin. 622 maybe 640 is another bin. 640 to 660 is another bin. 80 is another bin. 700, then 720, then 740, then 760, and then 780. Right? So these are the bin sizes given to us, or it has internally decided. So what histogram does is, after looking at the data, it decides that what should be a certain interval which will make sense to plot a histogram out of it. Now if I want to set that particular bin size, I can set it. If I want to set that interval, I can set it by giving some parameters through the codes, by doing the coding and all. Okay, within that histogram function itself, I can write something. Simply pass on the parameters. That is possible. The important aspect over here is to understand how to interpret this. Now, if you see over here, when we say frequency plot, the number of students which are appearing within a particular interval is given over here. Right? Number of students which are appearing within a particular interval. So this is the interval, right? 680 marks to 700 marks. There are around 150 people or students. One can again say that from 720 to 740 marks, the persons who have obtained this, or students who have obtained these many marks, are around 150 in numbers, and that is why it is called as frequency plot. Now it has got some limitations, so it has given up to 250. So we can assume that probably this line is somewhere around 300. So one can say that the students who have scored the marks from between 700 and 720 are around 300 in numbers. Right? So this is one interpretation, one sort of interpretation. Now you can definitely talk about the skewness of the data, because the left tail is slightly longer. So can we say that it is a left skewed or negatively skewed? Right? Which means that more of the scores are towards right side or higher side, you can say positive side. What is another representation or another interpretation we can come up with from the histogram? So what can be averages? So normally whenever we have a plots, whether it is bar plot, box plot, histogram, any plot, then when it comes to interpretation of the plot or analyzing the plot, okay, we shall always start with, all these, whatever we have learned till now. Okay, so 4 moment of business decision, basically 4 moment of business decision. So obviously we shall think about mean, median, mode of the data, or we can also think about variance, standard deviation, or range. All of them, or any one of them at least. Third moment, skewness, which we have already seen. Fourth moment, kurtosis. So we can come up with whether it is negatively skewed, whether it is going to have positive kurtosis. It is definitely going to have positive kurtosis. Negative skewness. Variance and standard deviation is, suppose, needs some calculation and all. So we can at least talk about range. So you can see here the data, the scores are ranging from 600 to probably 780. The range of the data is 600 to 780. We can come up with that. Mean and median or mode, we can discuss about this as well, right? So mode may be lying between 700 and 720 scores, because this is the tallest building we can see over here. Okay, so the scores like maybe 740 or maybe 720. So there is a possibility that more number of people have scored the same marks, or there is a possibility that as around 300 people are between these 20 marks, which means that there are lot of numbers, maybe 702, 708, 712, 715, 718, etc., etc., may have repetitions within the data, right? So that is one understanding we can come up with. And what is the average if suppose I want to find out or make a understanding of? So you can see here for 773 students, the score range is from 600 to 780, and the average seems to be around 700. The average score, the mean of this data seems to be around 700. And even the median, as we have seen, the left skewed data will always have mean, median and mode in this sequence. So mean will be greater than median, less than median, and median will be less than mode, right? So median is going to be somewhere here, mode will be somewhere here, because this is exactly the center point of it, and mean is going to be somewhere here. So we will find out these measures definitely, but from graph we can make out this. We can keep a note of it or something like that. We will get an understanding how the data look like, right? So these are some of the observations we can come up with when we see the data, right? And if suppose we want to have a double confirmation on that, we can simply go to the R codes and we can have it plotted, right? So if suppose the MBA files histogram is this we have seen, and bar plot is this we have seen. Now I want to see the skewness of this. Suppose, as we have seen that it is a left skewed, so if I want to see the skewness is a function over here. So but the thing is that over here, to find out the skewness and kurtosis, I need a package to be installed, right? So I will show. I'm going to describe this later on when we will see these basic scores. So I'm simply just invoking the library over here called moments, and let us understand what is the skewness of GMAT, and look at that. The GMAT skewness is negative skewness, right? It is a negative skewness. And how about the kurtosis? It is a positive kurtosis, because there is a tall building over here. You can see at the center, okay? And that is why we are having a positive kurtosis over here, right? So we have seen skewness, we have seen kurtosis. Now we will also see the mean, median and mode. So let us understand what is the mean of the GMAT. We have said that it should be around 700, and yes, mean is 711. What is the median? 710, right? And what is the mode? So mode is numeric. Mode is, though it is given as a function over here, okay, there is no direct function available to calculate the mode in R, right? So there is no direct function available to calculate the mode. So what we can do is we can calculate it by writing okay, let me take a pen. Okay, all right. Yeah, so mode is not a function available in R, but what we can do is we can use this, we can calculate this mode Alright, I was just trying to work upon with the pen, but it is not working for me right now. So no issues at all. So the thing is that the mode we are going to find out by writing a special function, and that is called user defined function. I will explain that as well later on, right? So the thing over here is, what we have seen is, after looking at the plot, we have seen the measures of central tendencies, we have seen the measures of dispersion. Measures of dispersion we have not seen, but then we have seen the skewness and kurtosis, that is measure of asymmetry in the data and measure of weakness in the data, right? And that's it. I mean, we have interpreted the data quite well, and this is just a beginning. There are a lot more we are going to learn, right? So we have learned how to plot a bar plot, we have learned how to plot a histogram, okay, and then we have learned how to look at the central tendencies or third or fourth moment business decision, or even if we want to calculate the variance of GMAT, then we can simply calculate it with this. So 860 is the variance for GMAT, and this is going to be the standard deviation for GMAT, and this is going to be the range of GMAT. So 600 and 780 is nothing but the range of our GMAT, that is a second moment business decision, right? So the two plots we have seen, one is bar plot, one is histogram, and alongside that we have also, while interpreting the plottings, we have learned how to use R code, okay, or functions, and you can see here very small functions, one word each, you can say, as far as the functions are concerned, and simply you will get the answers, or after executing those functions you will get the details about the data, right? So after looking at these two basics plot, one more plot we are going to discuss, and that is called as box plot, right? So for the same data I am going to explain how a box plot will be used, and this is going to be a very important plot, right? Because if you remember, I have said that within the data at times we may have some sort of outliers, and what are these outliers? These outliers are nothing but the data points or the values which are not supposed to be in line with, logically in line with the data. So maybe if the data is labeled as the married people's age, and now if suppose the age is in the age column, married person's age column, suppose there is a value called 3-year-old. So that's become an outlier, because the eligibility for marriage, of course if I am talking about India, then at least 18 years or 21 years, something like that, right? So 3 years become an outlier. It may be a typo error, there is an issue with that particular figure, maybe someone has mistakenly typed it 3 instead of 33 or 23, it is a possibility, right? Or 30, 0 has been missed, something like that. So those become outlier in that particular example. Now let us take another example of sales being going down, or economy going down. Now as we are into this COVID situation, now you can see a lot of businesses have got impacted out of it, right? Now what happens when we get this data for analysis purpose? Suppose we are sitting in 2033, suppose we are sitting in 2030, let us, after 10 years. Now people might forget, maybe after 2 months or 3 months, suppose a vaccination will arrive, and the things will become normal, maybe after a year or so, and after 8-10 years of that, people may forget, and now you are trying to analyze in 2030 the data for sales of cars, and the data is from 2000, I mean year 2000 to, let's say, year 2022. Suppose you want to understand this 22 years performance. Now all of a sudden you will find that from 2000, 1000, I mean 19, not 19, sorry, 2017, 2018, 2019, 2020, the sale of a car is taking a dip, it's going down only. Why it is happening? Oh, then you will come to know that in 1 year the GST implementation has happened, in 1 year the demonetization has happened, then because of that there was a slowdown, and then all of a sudden the coronavirus have come, okay, and because of that the economy has gone down, and with that even the sales of car has also gone down, or probably electric cars have come into the market, and that is why the sales of the regular cars, or this car diesel and what we say on this oil energy, which runs on oil energy and all. So the sale for those cars have gone down, right? So at 2030, now these figures for these 4 years, the sales of cars may look like to you as an outlier, because they are not in line with the data from 2000 to 2022. So maybe up to 2016 everything was okay, and from 17, 18, 19, 20 to 22, right, next 6 years the sales have dropped. Now you have to make sure that you will speak to an SME, subject matter expert. So you will decide after discussion with subject matter expert whether to take these values or not. But now the important question over here, why all this discussion when looking at Boxplot? So because Boxplot is basically used to identify those outliers. Right? So suppose you have 1 million data points and you want to find out the outlier values within that data. How you will find out? So you must need to have some sort of a graphical technique wherein you will understand at least at what range or at what values the outliers are present. So that then you probably by filtering process or something like that, you may remove those numbers or those values, or you may keep them still into your analysis. That is a part of discussion later on. Okay, but first of all we need to understand which are the outlier values. Okay, so Boxplot is one of the technique which gives us these values. So let us understand first the various components the Boxplot carries. So obviously a Boxplot is having an upper extreme, a lower extreme, a upper quartile, a lower quartile, which forms a box between them, our upper quartile and lower quartile, right? And then it is also have a median displayed, right? So normally this lower extreme to lower quartile, you will have 25% of the data point, and this median to lower quartile, another 25% data. From median to upper quartile, another 25% data, and from upper extreme to your upper quartile, another 25% of data. Which means ideally what we are saying is between upper quartile and lower quartile, we will always have 50% of data lying. Right? And because of this, Boxplot becomes very, very interesting. And this particular range, okay, this particular range is called as IQR. A range between upper quartile to lower quartile is called as IQR, which is also denoted by Q1 and Q3. So Q1 stands for quartile 1, Q3 stands for quartile 3, right? So IQR is the middle half of the data set, falls within the interquartile range. So if I have 500 observations or 1000 observations, the middle half of the observations will always lie between this box, right? So it will lie between Q1 and Q3, and the difference between Q3 and Q1 is called as IQR, right? So difference, it is the difference between. Right? So let us understand with the terminologies again. The box plot, this graph shows the distribution of the data by dividing the data into 4 groups with the same number of data points, that is 25%, 25%, 25% and 25% in each group. The box contains the middle 50% of the data, and each of the 2 whiskers, these are called as whiskers, these lines. Okay, some data points are lying in on this as well. The line which is connecting between lower extreme to lower quartile is called as whisker, and it also contains 25%, and this also contains 25%. It displays 2 common measures of variability or spread in the data set. That is why box plot becomes very, very important. And there are 2 different types of ranges when it comes to box plot. So range is, we have understood that minimum and maximum value establishes the range of the data, right? So it is represented on the box plot by the distance between the smallest value and the largest value. Obviously we know that rule, including any outlier. So an outlier can be below lower extreme or can be above upper extreme as well. I am going to explain this in Excel as well, so that you will get a better understanding of this, right? So because my outlier can lie above the upper extreme and it can also lie below the lower extreme as well. So if I take them into the consideration, then that becomes my range. But if I ignore the outliers, the range is illustrated by the distance between opposite ends of the whisker, that is upper extreme and lower extreme, right? So it depends that whether I am going to include the outliers for my range or exclude the outliers for my range, right? So outlier is nothing but that odd data point which box plot will be used to find out, right? Let us understand this box plot concept in more detail in Excel. So let me open that file. Alright, so this is the data in my sheet. Okay, so you can see over here, suppose the data is like this, which is a random data, and it can be, I have not labeled the data. We simply want to understand the mathematics behind the box plot, how it works, right? So this data, what I'm going to do is, first of all, we have to arrange this data into ascending or descending order. Why? Because if you have noticed over here, it works on the basis of medians, right? And if you remember, while learning the mean, median and mode, I have explained that why we use median, or why the median as a measure is come into place. Because mean, that is the average of the data, tend to influence by the outlier values. Like we have seen the examples of the salary of a MD and an executive CEO will be taken into consideration, then it will impact the averages for the fresher salary, right? So that becomes an outlier value for that business problem, or that particular values of the fresher salaries, right? the salary for the higher personalities will be the outlier values. Similarly, in this case, we need to find out or identify which are the outlier values. Suppose this is the example data given to us. So I need to find out whether the outlier values are there or not. So to find out those outlier values, there are some mathematical formulas, right? So first of all, and those mathematical formula are used on the basis of the medians of the data, right? So what I'm going to do is I'm going to arrange this data. So let us arrange this data from largest to smallest. So I'm saying expand with selection, no, continue with current selection, and you see here, now this data I'm going to put it over here, because here it is going to be the upper extreme and here it is going to be the lower extreme. Now you can look at this. Now there are 15 total different values, right? So median is obviously going to be this, because there are 3 and 3, 6 and 7 above and 7 below, 3 and 3, 6 and 7 below. So this is going to be my median, right? So Boxplot, when I pass on the data, first of all calculates the median for the data. So it internally arranges the data into the ascending or descending order and it calculates the median. Now after that, it calculates another median between upper extreme and median, and which is going to be this, right? And this is going to be another median. Oh, sorry. Q1 is going to be another median, which is the median for the data between this and this, right? So once it has calculated the 3 different medians, this becomes Q1, this becomes Q3. It calculates the difference between Q3 and Q1 by using the differentiating method, okay? And it is simply Q3 minus Q1. It is going to give me the IQR, okay? This is called IQR, interquartile range, as we have seen, right? The difference between Q3 and Q1. So this is going to be IQR. Now to calculate the outliers, it internally uses 4 different formulas, right? One formula is this, Q3 plus 1.5 into IQR and Q3 plus 3 into IQR. So it is just double of this, 1.5, and this is 3 into IQR. So it gives me minor outlier, it gives me major outlier, right? And similarly, and this is for upper fence, and similarly 2 formula it uses towards the lower fences, right? So here Q1 minus 1.5 into IQR and Q1 minus 3 into IQR. Okay, this is going to be my minor outlier and this is going to be my major outlier. So if we see the difference between these two values is 53, right? So this 53 has been used over here and multiplied by 1.5 plus the Q3 value will be added. So 98 plus 1.5 into 53 is going to be 177.5. So if there is a value within this data which is above this value, then that value is going to be the minor outlier. And obviously the starting point for major outlier with this formula is 257. Similarly, here because we are talking about the lower extreme means the lesser values, and that is why Q1, the value of IQR multiplied by 1.5 will be subtracted from Q1. Here it will be added into Q3, here it will be subtracted from Q1, and of course from Q1 again multiplied by 3 as well for major outlier, right? So minor outlier, major outlier from both sides, that is lower fence and upper fence, will be calculated with this formula, right? This is how Boxplot works. Now let us understand this in R. So let me show you how Boxplot gives us this. So same file I am using, MBA dataset, and now I am going to use or plot the box plot. Now let us understand this box plot and look at that. So this is a very basic plotting of the box plot. By default, it will be always plotted vertically, and these dot you are seeing over here are my outlier values. So the meaning of this is, many times, a lot of people misinterpret this by saying that there are 3 outliers. No, there are not 3 outliers. There are 3 outlier values. Now this value of 600, which is shown by this dot, you can have multiple 600 values over there, and these circles can overlap each other. Similarly, this circle, maybe 610 or 20 can overlap. 620 or 30 can overlap each other. So there may be multiple outliers. Okay, but as far as values of outliers are concerned, there are 3 values, right? So if I want to check what are the values, then I will simply say the $out way, and you can see here these many outlier values are there in my MBA data's GMAT column, right? So I will use this box plot, and you see here now this plot has been plotted as horizontal, right? So it is just tilted from vertical to horizontal, right? So to do that, what we have done is we have said box plot GMAT, I mean the data I have passed, and I said horizontal equal to true. That's it, and it will give me the horizontal plot. And if I say $out, then it will give me all those outlier values where outliers are present, right? So this is how we use bar plot, histogram and box plot to understand to interpret the data, to understand the data, right? And now for this, if you do all the calculations as I have shown over here, like 1.5 and 3 multiplication, etc., Q3 minus Q1 subtraction, multiplying this IQR and all, you will find out that these are the exact values. I mean the starting point and above, or starting point and below. Okay, these are the values. So definitely here, if you see from this plot, I'm going to have, this is my lower extreme, this is my upper extreme, this is my median, this black line is my median, this is going to be my Q1, and this is my Q3, right? So let me color mark it. So I'm talking about, this is my, I'm not able to write it Y. So this is going to be my Q1, this is going to be my Q1, this is going to be my Q3, these are my outlier values. So this is my lower extreme, this is my upper extreme, right? So definitely, if you see, the values are towards lower extreme, which means the formula will work out over here is my Q3 minus Q1 whatever value will be there for Q3 minus Q1. So let us calculate that as well. What is Q3 and what is Q1? So if I take the summary of the data, I will get it. So let me check. Okay, I'm taking summary of GMAT. Okay, I need to close this. So summary of GMAT, if I see, and you see here Q1 is 690 and Q3 is 30. So if I do that, 690 minus 730, which means it is 40. It's going to be 40. So 1.5 multiplied by 40 is going to be 60. So what is my Q1 value? 690 minus 60. So 690, which is my Q1, sorry, so 690, what happened? Alright, let me use some other mechanism to explain this. So if I use this formula as we have learned, so Q3 is what? 730. You can please watch in my console, I am writing it over there. 730 minus 690 is going to be, my value is 40. 40 into 1.5 is going to be 60. Now my Q1 is 690 minus 60, and that's 630. So any value below 630 is going to be my outlier. So this particular value is maybe 620, then 610, and then 610. So this is how we can recalculate or understand how the calculation happens, right? So that's it for today's session, friend. We have seen in today's session how to plot bar plot, box plot, and even the histogram. I hope you must have liked the video. If you have really liked the video, please hit the like button over there on the video, and for those who are new to my channel, also subscribe my channel so that you will get all these new upcoming videos which I am try to record every now and then, and you will get updated with all these topics. If you have any questions, please don't hesitate to write me through any of the mediums available of communication, right? I am there on LinkedIn, I am there on Facebook page, I am there on YouTube. Even my WhatsApp number is mentioned in Facebook page. A button has been created, right? And all that information I am going to post, or I am going to give in details of this particular video, and in every of my video you will find all my communication details, right? So please, for your questions or for your suggestions and guidance, and maybe guidance in terms of you need some improvement through in the training, or maybe the communication style, maybe the presentation style, the pace of the video, anything, any issues, you are free to discuss with me, or tell me your suggestions and feedbacks, and also your queries, right? So thank you very much for watching today's video. Best of luck. Bye bye. See you.